Yeah, hi everyone. Good evening all. So in the today's session, we will discuss week 8 and week 9 graded programming assignments. So we have only one question in each week 8 and week 9. So today we will cover both. And also we will discuss the problem statement of week 10, just explanation. So we will start from the week 8. Yeah,
Yes, sir.
Sanath, you go
Yeah,
on.
you can hear me, right?
Yes, you are
Yeah,
audible.
let me share my screen. So yeah, so you believe the screen is visible. So, so the week 8 problem statement goes where we have Chandrayaan 3, which actually successfully made its soft landing on the south pole of the moon and now started to excavate the moon's surface. The lunar landscape was a puzzle of craters, ridges, and valleys, much like the nodes and connections in a network. The team established communication hubs, each labeled with a number, representing vital communication points across the moon's surface. These hubs were connected by laser beams acting as directed edges, each with a designated bandwidth that dictated the data transfer capacity. So basically, we have, say, some hubs in the lunar space, and these are connected by the laser beams. And our task is to transfer the message from the source to the sink. So there will be a source hub and a sink hub, which will be denoted by 0 and n-1, where n is the total number of vertices in the graph. Our task is to find the maximum data flow that can be made between the source and sink. So as we could see that we have a source and sink, and immediately we have, say, some of the other edges. So we can think about this, this problem of, say, Ford Fulkerson's. So where we have this source and sink, and there's a very straightforward problem of implementing source and Ford Fulkerson's algorithm, but in an efficient way because of the constraints which we have. So the network will follow this. There will be only one source and one sink. Other than source and sink, nodes are represented numbers between 0 and n-1. There are no self loops that has been there. There will be no initial dead ends other than, say, n-1. For any pair of nodes, direction of edges between them will be single direction. There will be no there is no undirection. It's always a directed graph. So the first line contains two integers n and m, where n is the number of vertices of the residual graph and m is the number of vertices of the, I believe this, and m is the number of vertices, basically total number of vertices. The next m line will contain u, v, w, denoting the, actually m should be number of edges, I believe. It's not the vertices. Yeah. So next m lines contain three integers u, comma b, comma w, denoting that there is a directed edge from u to v. So this is what the problem statement is. So we have to print out the maximum flow. For example, let's take, and our constraints are where 0 less than n less than 10 power 4 and 0 less than m less, that is number of vertices are 10 power 4 and number of edges can be till 10 power 5, and u comma b, that is actually it should be 0 less than equal to u comma b less than n, and weight is basically till 101. That's our maximum weight. So suppose we have this graph where we have 6, 8, that's the 6 is the number of, say, vertices, and 8 is the number of the edges. So we could straightforwardly say that 0 is the source and 5 is the sink, because we already said that 0 and n-1 are the source and sink of this graph. So now we have edges which connect, like 0 to 1, there is an edge, 0 to 3, there is an edge, 1 to 2, there is an edge, 3 to 1, there is an edge, 3 to 4, there is an edge, 2 to 4, there is an edge, and then 2 to 5, there is an edge, 4 to 5, there is an edge. Now we have this graph, we have to somehow find the maximum flow in this graph. So when we go from 0 to, so first the Ford Fulkerson's algorithm goes like this. So when we have 0, first we have to find a route. So 0 to 1, 1 to 2, 2 to 5. So we found the path. So then what we do is we'll get the bottleneck, that is the minimum possible value, which is here 3. So then we'll draw an edge to 3 and we'll cancel every other, say, edge by 3. So that's how we do it, and we get this graph. Now we again find another path, which is 0 to 3, 3 to 4, 4 to 5, and the bottleneck is, of course, here also it's 3. So we'll have the residual edges. Now let us find another path, which is like 0 to 3, 3 to 1, 1 to 2, 2 to 4, 4 to 5. So that actually we find it, and the bottleneck is again 3 here. So we'll again have this 3 as the residual edges. Now we'll try to find any other path which existed where 0 to 1, 1 to 2, 2 to 8, 8 to 3. So there is a path again. Here we find that bottleneck is 2 because there is an edge which is less than even 3, which is 2. So we draw the residual things. So after this, we couldn't find any other, say edges which are like, say passing. So our total should be 3 plus 3 plus 3 plus 2, which is 11. So now let's try to implement. So what I have done is I use the algorithm called DINIX algorithm, which kind of does the thing. Yeah, let's choose. Yeah, just a minute. Okay, this was okay. Let me choose a Python solution, which actually could try to get things up. Week 8. Yeah. So, just a minute. Yeah. So let me share this screen. Yeah, sure. So yeah. So this is the same question where we actually, say uh, have the same thing. So I have just got this. So let's actually try to see the Pythonic solution. This is the same DINIX algorithm which is being given in the GitHub notes. If you could actually try to even see that let me actually explain. So first I have this class which says that there are edges literally where we have this flow variable and then we have the cost variable and the reverse basically for the residual graph, residual thing. So then I have with an edge actually this like say node or an edge. This now I have a graph. Literally, I try to construct a graph where first I'll have adjacency say matrix with this. I initialize an adjacency matrix so that I can represent the graph. And self dot v is v basically that is going to be self dot level basically. Then I have the level for everything. And for add an edge basically, if I wanted to add u comma v comma cost, I basically have the similar same implementation where I have a is equal to edge of, b equal to edge of, then self dot edge of u basically is an adjacency list. Sorry, it's not a matrix. Maybe that way you can identify this. And now for graph, the graph operations basically it's a very naive BFS where I could find the shortest path for say for calculating this path. Basically, I have implemented a BFS and send flow. Send flow is a function which actually checks if there is a flow from 0 to 5 because now if suppose I cannot go from 0 to 1 to 3, so it will like it will try to calculate the bottleneck to when I send flow where I use my BFS and then try to get the bottleneck. And DINIX max flow. DINIX max flow is a very again say it just uses this self flow send flow and BFS to what to say calculate. First I have this where basically I try to send flow is just for say from 0 to any one of the vertices, but so this DINIX max flow what it does is it calculates the max flow of the entire graph. So where I start from while self dot BFS comma s comma t this source comma target, I have my start. While true, I'll send flow this. I'll try to get the bottleneck. If there is no flow, basically, if there is no flow left, I'll break it and I'll like calculate the total, and so that I can get the maximum flow in the entire graph. And it's just the straightforward implementation of say get from the inputs. So there are other implementations to C++ and Java and C2, so which actually does the same task. So believe if suppose someone has any doubt, I could actually try to. Yeah, I believe there's a chat. Yeah. So week 10. Yeah, okay. So okay, that is like in week 10, programming assignment, all my test cases pass except for the first case on my code, which is strictly according to the consent, so it made me pass. Minutes. So I believe this is let me check it's I think so it's a week 10. So let me actually go through the week 10 question for you. So So I believe that question is week 10, like I just don't know which question in the chat is being done. Which question, if you could say, then let me try to check. Google. See if I can see out back. Okay. Please check it. I have also written about. So yeah, question 1. Okay. So so let me check this, but yeah. So the question goes like this. So imagine you are in a magical world and you suddenly see a jackpot. You're excited and see that the pot is empty, but there are set of rules, and if you follow them, you can get the gold coins instead of copper coins. So basically, that's yeah.
Sorry to interrupt. I think you are sharing your
Okay, sure.
Chandra.
Yeah. Thanks for that. Yeah. I'm sorry for this. Yeah. So yeah, now is it visible, right? Yeah. Thanks, Pushpin. Yeah. Yeah. Is it visible right now?
Yes.
Yeah. So the week 10 programming assignment question goes like this. So after this, I'll try to check the chat and let me see what's going wrong there. So imagine we have a magical world. Imagine we are in a magical world and we suddenly see a jackpot and you're excited and see that the pot is empty. But there are set of rules, and if you follow them, you can get gold coins instead of copper coins. Imagine you have some copper coins with you and somehow you should be able to get n gold coins from it. There are 3 rules which you must remember about the jackpot in order to get the gold coins. If you place 1 copper coin inside the pot, then you'll get 1 gold coin. So this is the first condition. And if you place 4 copper coins inside the pot, then you will take note of it, how much copper coins till so far you have actually put it. And if you place 2 copper coins inside the pot, then the pot will toss out as many gold coins as it remembered. So that's what the question is. So the outcome is you have to get the minimum number of copper coins that can be spent to get exactly n gold coins. If you toss 1 coin or 2 coins at once into the pot and there are not enough gold coins left in the pot, the pot will not toss out any gold coins. So this is like the base case, if you can think of. So for example, we have we have to toss 5. We have 5 copper coins, and we have to get say 5. We have to get the 5 gold coins. That's what the question is. So maybe we have an infinite say supply of copper coins. So how many copper coins we can put in? So say we can toss 5. So what is the minimum possible thing is we have to put 5 copper coins to get the 5 gold coins. So other than that, there is no minimum number of we have to compulsorily spend the 5 gold coins. But in case of 20, say if we want to get 20 gold coins out, so what we will do is we will first spend 5, then we will remember this 4 basically. We'll spend 4 by remembering the 5 coins, and then we'll get 2, 2, 2, where I'll get 5 out, then 5 out, 5 out, 5 out. So that way I get 20 gold coins out, but we spend only 15 copper coins. So that's how the test cases are. Now let me actually check the chat box. Yeah. So week 10 of n into t is not getting accepted. So all the test cases have number greater than 90,000, but my code passes. So basically, okay. But I believe it should pass your test cases with the given constraints. If that should be possible still. So
my issue is ki
yeah.
my code has been accepted by 7 out of test cases, 7 out of 8 test cases. But
Okay.
first test case
Yeah,
is
the
not getting
first
passed.
test case is little bit, it's one of the bigger test cases if I remember when I was framing the question.
But
But
is
yeah,
it totally fitting into the constraint of L less than equal to 10,000? Because all other test cases also have numbers greater than 9,900 and they are
mhm.
also getting accepted.
But it might be basically because uh, I think so it should work. Let me check the rules, but still, if suppose I believe maybe if suppose something is wrong with the constraints, or like if suppose it fails, because I have tested and all my codes worked in the 4 languages. But if suppose there is an issue, then I'll like say that we if we'll try to like solve that some sense. That is an issue. I'll just check through that some sense.
I have also given a code which you can use to know that,
Okay.
because there are only less than 50 numbers that we have to check for.
Okay. Okay. So yeah. I'll just go through it. But yeah, I'll just check the number of test cases in the first test case. If suppose it doesn't match the constraint, say 10 power 4, then I believe it could be test cases 50 and then 10 power 4. Like if you that could also be the case, right? Some sense, because the maximum number of test cases, and because it will be so that will be very huge, right? The other things, the number of L might be, say, it could be. Try to count the number of test cases with the inputs and just I believe it should. But anyways, which language is C++, right? I mean, you use.
Yes, sir. So the TL is not coming.
Hmm.
Also, my code is almost about off, and you can say it is very much precise. But
I couldn't see your code. Is it in your Discord? Like, is that?
no, I have written it on my own.
Okay, okay. I mean, did you post it somewhere like for the?
No, I have not
Okay.
posted that.
Okay, that's fine. Yeah. So it should work. I mean, if I'm not wrong, but still, let me see if suppose there is any problem with the constraints. I mean, believe.
Only the first test case.
Okay, only the first case.
First, private or public?
Private test case, which I cannot see.
So what is the output you're getting? Maybe like for the case.
I'm getting wrong answer, and all other test
Ah.
cases have been passed. Second, third, fifth, eighth.
Wrong answer. Okay.
Yes, sir.
Then there isn't maybe. Then it's not TLE, of course. Then the code works, but maybe there is something else we have to consider.
No, so they would just check the corner case of the problems. Okay.
Yeah. Try to
Okay,
check
so
the
there
corner
may be a
case.
chance there may be some corner case is missing, and because of that your code is not passing the test case. Just
That's wrong answer.
figure out the corner case.
Exactly. So wrong answer, I believe, then should
No,
be.
sir, like in the first week also it happened that when the constraints were given for 10 to the power 9, for something less than 10 to the power 9, and when I used int, so it was not accepting, but when I used long, then it accepted. So it might be that test case is exceeding the
But actually, if suppose it exceeds, then you will be getting a TLE most probably, not a wrong answer, I believe. Like
No,
you will.
my answer, my code is actually such that it will not give anything other than, it will never give TLE.
Okay, so
No,
then.
because of that, we are saying that maybe some corner case is missing from your code. We are not saying that your code is giving any TLE error, this type of error.
Yeah.
Maybe it is giving
Yeah,
wrong
that's
answer
what.
because of that. Some corner case is not covered by your solution code.
Yeah, that's what we think. Maybe.
Okay, so just think about that. What are the possible input may come in the private test case? So just update your solution code accordingly.
Yeah.
Yes, sir.
Okay.
Let's see. Let's see.
And
while
or you
discussing
can
the
also
answer.
connect with us through the Discord and Google. Okay, but don't post the your solution code on the forum. Okay, you
Yeah.
can direct
Yes,
mail to us if you
Yeah.
want.
That should be fine. Yeah.
So
You can mail us
also,
or Discord.
so I had the problem with question 6 in week 8 quiz assignment.
Week 8 quiz assignment.
So that should be considered ambitious now, because even the sir got confused.
This one.
Yes, sir.
Yeah. So as I think I have already replied to you on this.
So, but even if
Correct now?
the teaching assistant sir is getting confused in the question,
That's possible. Now they are also a students of the IIT. Okay, so there may be a chance they missed something, but is there anywhere it is written that we are asking the possible output for this?
so but other students are also were also confused with the question.
No. Most of the students mark the correct answer also. Maybe you are just seeing some 2-3 students, but we
So-
have the record. Yes, so many students mark the correct answer for this.
So if I took this doubt in the live session and I have got
Yeah, because of that,
misguided.
you are saying that you discuss this question in the live session, but first thing, you should not discuss any graded question in the live session, okay, before the deadline.
So I
Or
didn't ask the answer. I just asked what the question wants us to do.
so I think if you getting the understanding of the question, so directly you will get the answer also for this question.
Yes, sir. So that's what I asked. That what the question wants us to do, and what he said that you have to do like this. I solved it like that, and I got the wrong answer. So it's not my problem, my mistake. No, I was
So
not
because
able
of
to
that,
understand the English.
because of that, we actually said in the live session that do not discuss this graded assignment on the forum as well as the live session before the deadline. But otherwise, you can, if you want to discuss, just join our session. That session is actually scheduled for the practice purpose only, the practice assignment purpose. Okay, so there is no problem. Many of the students have marked correct answer, so we cannot change the answer at that time. Otherwise, we have already updated many questions in the initial weeks. Once we found,
No
okay.
one answered on the Discord also when someone asked the same doubt.
Yeah, so because of that, we don't want to discuss the graded assignment before the deadline. If anything wrong in the question, definitely we will change.
So the wrong was that we were not
This
able
is
to
just
understand the question.
a misreading of the question. This is just a misunderstanding of the questions. When you are reading the question, you are missing something. Okay, so this is not the problem with the question. This is just or you have discussed this question with the in the live session. So because of that, you are confused.
No, sir. We never went to reached to the answer. I just asked for the question statement and nothing else.
And you are also posted on the Discord forum, so maybe some other students is also mark the incorrect. That should not be happen
Yes.
with the graded questions. You should not write something like this.
So
Okay.
I didn't ask the answer. I just asked what the question statement is trying to us.
So question statement is clear. I am not able to find any wrong thing in the question. So the question is straightforward, asking the solution, and option is also related to this. Why you are? I don't know why you are confused.
सर इतनी क्लियर होती तो वो सर भी गलत आंसर थोड़ी ना बताते कि तुम इस तरह कर दो.
क्यों नहीं बता सकते?
सर अगर इतनी क्लियर होती तो सर क्यों बताते सर?
First thing, actually, he is not aware of these assignments. Okay, so they are just allocated to the to discuss the practice problems. They are not creating these questions. They are not aware of these assignments. So if anytime you just ask the question, so maybe they also misread, and they I think he also posted on the forum. He misread the question. Okay. Otherwise, we have already updated many questions before. So if anything is wrong, anything is ambiguous in the problem, we definitely updated the answers. But in this problem, we are not fine, and we have already used these questions many times before. Okay.
Sir.
And what is the problem with the week 11 questions? They just posted that image is not there. Practice question. Sorry, Sarnath, can you share your screen once again?
Yeah, sure, sir. Yeah, I'll just a minute. I just close it. Like, 1 minute, just a minute.
Okay.
Week 11, right?
Okay. Week 11 practice assignment.
Yeah, practice
Theory assignment.
Practice theory, right?
Yeah, this one. Correct.
Yeah. Yeah.
Yeah, Dev, what is the missing in this question?
Is it the first question?
First and second, he's asking that there is a sentence here, the solution worked out by your friend. See next page. Where is this line? Oh, this one. But she gave you the answer without taking. No, this, I think this line, last line. Here are the solution worked out by your friend. See next page. Can you match the solution to the questions? Next page.
Where is it?
This line number, but starting from but next line, yeah. This
Here, okay. Here are the solutions. Okay. Okay, this next page is not there. Okay.
Can you match the solution to the questions? Okay. So we will check this thing about the questions creator. So this is the previous terms question actually. So we have to figure out that if anything is wrong in the question, so we will update.
Yeah.
Okay. Yeah. So your friend, Sarnath. Yeah,
Yeah.
Pushpen, you can go ahead.
Sure. Let me share my screen. Okay, so I'm guessing my screen is visible now.
Yeah, it is.
Yes.
Yeah.
So the week 9 problem statement is basically a derivative based on the max flow and main cut duality problem that we have. The problem statement goes something like this: that an extraterrestrial being has landed on Earth. Let's call him anonymously annoyed. A has learned the language of humans, but is annoyed that humans are bad at communications. They say something when they mean something entirely different. So he comes up with a plan to understand the factors contributing to this miscommunication. To perform this analysis, A chooses to study the transfer of information, that is transmission, and debug them. For that, he shares information with a bunch of people that are part of a communication network. He then chooses his target to whom he wants the information to flow to. Help anonymously annoyed figure out the minimum number of transmissions he needs to monitor to solve the biggest mystery he has chosen to solve. So the problem statement has this is given this figure. So this is the being A, and this is your communication network, which has 1, 2, 3, 4, 5 individuals part of the communication network. And let's go to the input as well. How is it given? So this is your actual problem statement. You have given constraints. This explains how the input is going to be given for that this problem statement. So first line would contain 3 integers, the number of individuals that are part of the communication network, the number of transmissions in the network, which is represented as edges between those 2 individuals. T is the target individual, can say target individual to whom the information A is interested in sending to. The next line is just the representation of the edges. You have 4 edges. Not that. Okay. So you have you're given these edges, and the next line, which is the second line, gives you the number of individuals within the communication network with whom A is going to share that information. So here you see that the first number itself gives the number of individuals. Then within the each integer next, let's consider this as L. Next L individuals that are part of the communication network will receive the information from A. The next M lines are the edges within the communication network itself, which is this. So 1, 2, 1, 4, 2, 4, 2, 3, and 3, 4. If you look at these, you would most likely find these edges part of this, these edge representations within this communication network. I hope the problem statement and input is clear up till this point. No response, I'll take it as a all good sign. So yeah. Okay. So the now the idea is that because he wants to monitor the communications, first is the idea of setting up the entire graph itself, which is going to be used for that entire communication. So what you will end up doing is you will be creating an edge between A and 5, A and 1 is, let's call it 0 instead of A every time. So 0 to 2, 0 to 4, because that is how what we have represented here, that the 0th node would share information with the node 1, 2, 4, and 5 within the communication network. So you create this edge. Now the only part is that it's a simple implementation of admin cards network flow, where you figure out what is the minimum number of edges that needs to be, that A would choose, meaning possible. There could be minimal, zero node can possibly monitor all the transmissions within this communication network, but it starts with the minimum number of that's the problem statement that has been constructed this way. So you need to give out the minimum number of edges, minimum number of transmissions he can use to monitor this, so that the information is flowing to the index, which is specified here. Third, so simple implementation of admin carbs, you figure out what is the maximum flow within this edge. Now, because of the fact that every edge, there's no there's no weighted edge. Each edge would have essentially would have a weight of 1, and you just need to send flow using the same algorithm. That's pretty simple, and the output is the max flow is the min cut, meaning as soon as you remove those edges, that information stops from flowing from 0 to 3rd index. So that is the entire intent behind this problem statement. Now, looking at the solution for this, it's basically you have this set. This is the initial setup. You get the number of vertices, number of edges, and the target. This is just help us sort of thing. This is actually because of the fact that 0 index is not part of this. A is still not part of the communication network until you start making it part of the communication network. This is the setup.
Pushpendra, are you sharing some code?
Oh, yes. Sorry. Thanks. Let me share that another screen. Check if I'm, yes. So I'm guessing the screen is visible now. I can see it on my end. It's visible. So this is the initial setup where you have this number of vertices, number of edges, and target, which is the first line of input. This particular line is just ensuring that the 0th index that we have for A is considered as part of the communication network. You set up the max flow, class object, which is just what has already been discussed, covered in I think in the lectures as well. This is the part where you set up the edges of A with the communication network, and this is just the out. Then comes the output of admin carbs. Now, how does admin carbs work? We know, but I'll just go through that. So the idea is you have this source and your targets. You figure out you figure out whether there is a whether there is a reachable vertex from source, meaning which a reachable path from S to T using the breadth first search itself. If it is, we send one flow on onto that path, and within that itself, once we send that flow, we also create your residual graph as well. So as long as the as long as the graph itself has a path from S to T, the source until and unless the source is not reachable to T, you keep on working on this loop. You figure out by that time, as soon as your max flow, meaning in the sense, the point where the flow, you cannot send information from the source to target. That is the maximum flow, your number of edges in this case, that would give you the min cut as I think I'm not confusing too much, but yeah, that's the entire solution here for you on the admin carbs. That's pretty much it. I hope that wasn't too overwhelming or confusing. What was it? The next is the explanation of week 10, right?
Week 10, question 2.
Yeah. Okay, so the week 10 programming assignment 2 is actually pretty straightforward, but yeah, the problem statement goes like Alice is about to embark on a journey into the wonderland. Before she does that, she wants to pack food with adequate nutritional value, and she wants to ensure that she carries the minimum number of items on her journey. Help her figure out the minimum number of items she can carry. Alice has infinite supply of each item. The constraint is that the number of items to choose from is at most 100, and the nutritional value she needs to carry is less than 10 raised to power, I think, 6. At most 10 raised to power 6. The first line contains 2 integers, 2 space separated integers, which is n and m, and number of items to choose from. M is the nutrition value she needs to carry. The next line contains the nutritional value of each of those n items that Alice needs to choose from. So if that is possible, I mean, the output needs to be, you need to print the number of items she can carry if it is possible. If not, -1 is your output. Now, in this example, you are given 4 items and you need to choose 10 as the nutritional value for those items. Now, there are many possible ways to do that. So 2 times 5 is a possible configuration for this solution. 2 plus 3, 2 times 2 items of 2, first item, and 2 for the second item also gives you a total of 10, which would be like 4. But the minimum number of items, the count that you're looking for, would be given if you select this third item twice. So that is what is the solution here. It's pretty much straightforward. It's only figuring out how would you actually approach this problem. Let's not give out the solution right now. But yeah, I hope the problem statement is pretty straightforward for anyone, and no confusions. Okay. I think
Okay.
there won't be any questions.
Yeah.
No one is there.
Okay. Yeah. Okay. So thanks, Pushpin.
Sure.
You can stop sharing. Okay, so if anyone have any doubt, you can post on the Discord forum and as well as the Google groups. We will revert back on you on the forum. Okay, so we will meet you in the next week. Okay, thanks everyone.
Thanks all. Bye-bye.
Thank you.
Bye.